Hi everyone. Today I wanted to make a video on why, how, where did this exponential function come from? At equals p times e raised to rt. So before even we want to know the proof of this, I want to have a look at this formula that how much the money grows to after t years. So this we already know that the amount in the bank deposit. Let's say you deposit the amount p dollars, and then it is 1 plus r divided by how many times do you want to compound the interest in a year, and because of that you have to multiply n times how many years. So this we already know. So what I did is in this example, just to get an idea of how the money grows, I I I consider depositing $1. So this is the P. Then assume the bank is giving lending with the interest rate, giving us interest for 100% annum. With each year, you get 100%. Now, what is 100% means? It is 100 divided by 100 is 1. So your R is 1. Now I'm taking this just to get so that this becomes easy calculations. So amount to deposit in the bank is $1. The rate of interest is 100%, which is 1, and I'm keeping it for 1 year. Now, when I keep $1 in the bank for 1 year, so if it is 100%, so you get back your $2, right? So 1, and you get $1 back because on your dollar you get $1 back because it's 100% interest. Now the question is, how much will I get money? I don't want to calculate interest once a year. I want to get calculated monthly maybe. So the n becomes 12, and then I want to check on how does if it is daily interest is calculated 365 days in a year, and if it is hours, it will be 365 multiplied by 24 hours because a day has a 24 hours. And if I want to calculate in minutes, it will become 365 times 24 times 60. So each time you plug in this value, and in the last class you have seen, I showed on the desmos.com, we put the equation. Now in this example, and you can clearly see the money that is put in the 1, so that's like 1. This is the 100%, which is 1. And here the x is this one. The n is, I put it like an x, how many times here in the Desmos. And we have seen, when you put this x here the same, this n, which is changing, so n, so I use x here. And then we have seen the graph of this. It approaches to a number which is 2.7182, and it becomes like an irrational number. So that number was called E, natural number. And we also have seen the graph, this one. So the graph starts with, you can't have x equals 0, so there is a undefined and x equals 0, and the graph clearly says the values of this function, they go on increasing. In the beginning it goes faster, you can see the rate here increases very fast, then slows down, and then it goes slowly, and it approaches to a number E, which is 2.718. Now my goal is, how does this use in different situations? How can we use this for, maybe we want to know how the bacteria, the scientists do study research on how does the bacteria grow, kind of thing. Then you can also think of the population growing, or you can think of radioactive substance decaying, half-life period of a radioactive substance, those kind of problems. So my goal for this video is just to show how did we get this. So I will begin from here. So the first thing is I'm using all the variables. So that's the main thing we need to keep in our mind, that if you have a 1 plus 1 over the same x, which is the denominator is up there, then it approaches to 2.782. So this is this is y equals 2.7182, and is the horizontal asymptote. Okay, let's start here. Let's check. So I'll start with this one equals p, and this is a quotient of r and n, and there is a n, right? So I want to manipulate this and divide r here. Let's see what happens. So 1 plus r raised divided by n, and then there is a n. So this time I'm going to divide by r. Now if you divide by r, you have to also multiply by r. Let's see, why did I do this? N times t. Agree? And then I'm going to use the power rule is m a raised to m times n is a raised to m the whole raised to n. So this can be written as p, and I'm going to use the bracket here. So it is this 1 plus r raised to n, and this n over r. So let me write this. And then the bracket raised to RT. Okay? So now somehow I want to get 1 over x here. So this one is 1 plus 1 over x. So I'm going to replace here. So let's replace. So r over n. So this r over n. Let me replace it by 1 over x. But because this is n over r, which is a reciprocal of r over n, that means if I flip this using inward tender, this n over r, this will be x over 1, correct? Which is just a x. So now let's replace this p 1 plus 1 over x. So this part will be right here. So that will be 1 over x raised to n over r is x, so that will be just a x here, and the whole raised to this rt. Okay, now we've seen this when x is very large number. So what that means is, if the interest rate is calculated continuously, so that's what this means. So when this x, basically I use n in the formula, it is n here. So now if this x is very large, in other words, you're using not only monthly, daily, hourly, minute, every second, and even a fraction of a second. So you're calculating interest continuously. This whole thing approaches to, see this, when this is very, very large, this is a large number, and this also is a large number. So it's like the number approaches to e. So this can be replaced by, so as x is very large number, x approaches large number, this whole thing will be p e r t, which is same as p times e raised to rt. You're done. So that means if the money is, let's say, whatever, $1, so this number, the whole thing, this was the case in the beginning, you have this, but now it reduces to p e raised to rt. So the question is, when do we use this formula? So this part is p t. So the amount for t, whatever the years is what all you need to know is what is the percent or rate of percent per year. What is the interest per? What is the interest per year? So this is that R, which, let's see, the bank gives, I'm just taking an example, the bank gives 5% interest. So how much money will be in 5 years or 7 years? So you want to know if it is 7 years, what will be your amount? So for the continuous calculating of the interest, the amount will be, so the money that you put, let's take it, you're depositing $300. Because I'm just giving an example, so it becomes 300 times e raised to, so the R becomes 0.05 because 5 divided by 100 and you get 0.05 and times this t set, and you can get the answer. Basically the model is A is t, this is how you model the function, and that's it. And you can figure out any year. So as I wanted to show, where did this formula come from? How did you get this formula? So this is the, one more thing is you have to know that the growth rate, the growth factor, this is the growth factor, this green color, growth factor. If you see that this problem, in this case, the growth factor is this part, see this? And because you are doing continuously, this part, which is actually b, so we write the exponential function a t is p times b raised to t. Remember, b is 1 plus r, but then we want to know how many times, that's why that n comes. But what I'm trying to say is this b growth rate, this b that you have here is less than this e raised to r. So that's why we see the money grows faster in this example than if you want to do monthly or maybe daily or hourly. But that's the fastest gives you the more amount. So anyway, so the goal is the learning target for this was just to prove that if you know this part, P equals B times B. Everybody is aware of this formula. If it is P times B raised to T, but the point is, how does, if you are making it continuous, calculating the amount in a fraction of a second, then what is the growth factor? So the growth factor is e raised to the power r. Okay, so that's what I wanted to show, e raised to the. Okay, that's all I wanted to show. Thank you for watching, and as I said, trying to show most of my videos is why the formula exists. So we have seen today. I just wanted to show, hey, that expression approaches to E. So where did the E come from? Was the question. And here I wanted to show that this formula or this thing reduces to this one when we want to do continuous calculating continuously. We want to know each and every second how much so that could be a bacteria population growing or population growing, anything. Okay, hope that helps. Thank you so much. Keep watching my videos, and as I said again, just wanted to know why this formula exists, why it is E, how did you get that E from, and then there's here, where did this formula come from? AT equals P e raised to R. Thank you for watching.